Module 3, a closer look at the epidermis. The epidermis is composed of stratified squamous epithelial tissue. Remember, that means it is made of strata, or layers of cells that eventually become squashed. You can see the layers in this image. In the lowest layer, we have the stratum basale. You can see how it undulates as it lays on top of the dermal papillae below. It's a single layer made up of cells continually undergoing mitosis. As new cells are made, they are moved up into the layer above, called the stratum spinosum. This layer is several cells thick. The cells in the stratum spinosum also undergo mitosis. Within these two lower layers are cells called melanocytes. Remember that cyte means cell? Well, melanocytes are cells that produce a class of pigments called melanin. They are cells that have long extensions called processes. When the melanocytes make melanin, they package it into vesicles using the Golgi apparatuses. The vesicles move out of the cells and into the processes. Then the cells of the stratum basale and the stratum spinosum utilize phagocytosis to engulf the processes that have been filled with melanin. That's how they take in pigment. Now, there are two main types of melanin in skin and hair. Eumelanin is dark in color. Pheomelanin is reddish in color. These two pigments influence your skin's color. Every person has about the same density of melanocytes in their skin, but there's a great difference in how much melanin those melanocytes can make. It's affected by a person's genetics, hormones, and exposure to sunlight. That is why there are so many amazing skin colors, even though we all have the same amount of color-producing cells. Melanin also serves another purpose besides provide color. It helps to protect the skin from ultraviolet radiation. You likely already know that the word radiation is not a healthy-sounding word, and you would be correct. Living cells can die if they are exposed to too much radiation. Radiation from the sun is the major cause of skin cancer in humans. The most dangerous form of skin cancer is a melanoma. A melanoma is an uncontrolled mitosis of melanocytes. That means that they continuously reproduce. Another type of skin cancer is called basal cell carcinoma. It is the result of an uncontrolled mitosis of cells in the stratum basale layer of the skin. This is a type of cancer that can be cured if it is removed surgically. Squamous cell carcinoma is caused by stratum spinosum cells. It's slightly more dangerous than basal cell carcinoma, but it can be removed by surgery too. People who have had severe sunburns have an increased risk to all three types of skin cancer. Yet smaller amounts of sun exposure to our skin is a good thing. It helps the skin produce vitamin D. Now, the next layer of the skin above the stratum spinosum is the stratum granulosum. This is the layer where the skin cells begin to die. They are further and further away from the nourishment provided by the blood cells in the dermis below. Cells in the stratum granulosum produce the protein keratin. Though the cells in the lower epidermis can also make keratin, the cells in this layer make a lot more. Keratin is an important protein because it gives skin its waterproof feature. Keratin keeps water in your body from over-evaporating out, as well as keeping out too much water from entering your body when you swim or take a bath. If a person has very bad burns over a large portion of his body, he is at risk of losing too much fluids because of lack of the protection from keratin. The next layer above the stratum granulosum is primarily found in the skin of the palms of your hands and the soles of your feet. It is called the stratum lucidum. Cells in this layer are so far away from the dermis that they are all dead. The outermost layer of epidermis is the stratum corneum. It is made up of about 25 to 30 layers of dead keratinized cells. These are the cells that will continue to flake off in a process called desquamation. So by looking at the layers of the epidermis from the deepest to the outermost, you can see that the cells in each of those layers have different characteristics. Beginning at the stratum basale and moving upward, cells slowly begin to die through the process of keratinization. The two lower layers contain cells that are still living and can undergo mitosis. But once they hit the stratum granulosum, they die. By the time they reach the stratum corneum, they are completely keratinized and begin to fall off the body, continually being replaced by cells coming up from below. So your epidermal cells are moving outward in a giant conveyor belt-like process so that you replace your skin every few months. but you know that your skin is thinner and more fragile in some areas and thicker and more protective in others. So we can make a distinction between thick and thin skin. Thick skin contains all the epidermal layers I just talked about, and the stratum corneum has lots of layers of keratinized cells. You have thick skin where your body experiences the most friction, such as the palms of your hands, soles of the feet, and fingertips. Thin skin has no stratum lucidum. Additionally, each of the other skin layers has fewer cells than the thick skin does. So thick skin and thin skin have to do with the layers of the epidermis only, not the dermis. Module 3, the integumentary and skeletal systems. Experiment 3.1. A closer look at the skin. In this experiment, we're going to take a closer look at the skin. Now that you have a little more information under your belt, we are going to look more closely at a slide we've already looked at before. The goal of this lab is to get a better understanding of what the dermis and epidermis look like and some of those regions. So we're going to take our human skin slide, not the one with the follicles or the hair follicles in them. We're going to put that underneath our microscope at 40 power. And you want to look for a darkish wavy line at the top of your slide. That darkish line is the epidermis. Now, center on that epidermis area and go ahead and focus to 100 power. And center it back again. And focus. All right. At this point, you want to understand that you can start to see some of those layers of the epidermis, some regions. You want to use the figure in your textbook, figure 3.4, as a guide to help you figure out what those layers are. But you'll hopefully be able to identify most of the layers of the epidermis that you're looking at. You may not have the stratum lucidum. You may not be able to see that, and that's okay. If you can't identify it, that's all right. But make an illustration in your notebook identifying at what power you're looking right now, and identify, if you can, the differences between those layers and why they look different, why you're labeling those. Notice things like the change in the cell size, the size of those cells, and their shapes within those different regions. That's going to help you identify what regions they are. And also take a look at the dermal papillae. How their size is changing. Now go back to 40 power, and then we're going to take a scan over the slide. And this is going to give you a good overall look at the difference of thicknesses between the different layers as they change going from the top of the sample all the way down. And so at this point, go ahead and draw, this is now 40 power, another illustration in your text showing that, and maybe making a few notes as to how you were able to identify the different layers using the illustration in your text as a guide as you do that. When you're done with those illustrations, you can go ahead and clean everything up.